Episode 54, titled Optimize DLP, UTM, NAC, and Quality of Service, we frame these platforms as policy enforcers that align directly to data value and business flow rather than as generic security widgets. The practical idea is to write policies in the language of what matters: specific information classes, named workflows, defined users and devices, and measurable performance, not in vague technical slogans. When these services are tuned to that center of gravity, they protect what is precious without tripping what is productive, and every action yields an artifact that explains itself. The outcome you want is simple. Important data is handled as intended, unsafe paths are blocked with clear reasons, and necessary work proceeds smoothly because the guardrails match how the organization actually operates. Data loss prevention, or DLP, begins with goals stated plainly for each channel. Detect only for visibility, block to prevent an unsafe transfer, or coach to guide a user toward the sanctioned path. Those goals must be scoped by specific data classes such as customer identifiers, source code, or financial reports. By channels such as email, web uploads, removable media, and cloud sync, and by destinations that differentiate internal, partner, and public endpoints. The most coherent programs start small. Pick one or two high-value classes and map them to the few channels that carry most of the risk. Each policy then names the intended behavior, the evidence you expect to capture, and the action that follows. When intent drives scope, you avoid sprawling rules that promise everything and deliver friction without clarity. Tuning DLP to reduce false positives is both craft and discipline. Fingerprints derived from canonical exemplars shrink noise by targeting the distinctive structure of protected documents, while exact data matching focuses on concrete values such as account ranges or contract identifiers. Proximity and context rules add common-sense guardrails, requiring that sensitive tokens appear near confirming keywords or within recognized document formats. Where unstructured content is common, you can lean on dictionaries and pattern validators, but temper them with thresholds and co-occurrence logic so a stray number does not set off alarms. The rule of thumb is to let real signals accumulate into a confident decision, and to preserve the matching evidence so investigators can review why the engine acted. Good tuning turns DLP from a blunt detector into a precise policy instrument. Unified Threat Management, or UTM, stacks consolidate inspection features, but they should be enabled deliberately rather than all at once. Activate the high-value engines that align with exposed services: stateful firewalling, protocol validation, targeted intrusion prevention for the protocols you actually serve, and web protections where you terminate HTTPS. Disable redundant processing that adds latency without new insight, and place decrypt and inspect only where you have a legal basis and a clear performance envelope. Sequence matters. Packet classification and fast denies should occur early, deep inspection where necessary, and logging consistently across features so a single flow produces a coherent record. The test for every box you tick is simple. What risk does it address? What artifact proves it worked? And what is the measured runtime cost on the traffic that pays the bills? Network Access Control, or NAC, earns its keep by verifying device identity and posture before granting a foothold on production networks. Identity can be certificate-based for managed machines and federated for users, while posture checks attest to patch level, endpoint protection status, and disk encryption without relying on brittle agent tricks. Successful devices land in segments that match their role, while non-compliant ones are routed to remediation enclaves with access only to update services and help portals. The key to adoption is making the right path the easy path: automated enrollment, short-lived credentials, and clear remediation messages that link a device's state to the policy outcome you enforced. When NAC is steady and predictable, support tickets fall because people experience quick, understandable decisions rather than mysterious denials. Quality of service, or QoS, keeps security from starving the business and the business from drowning security. The guiding idea is to align bandwidth, queuing, and priority to critical services: first real-time collaboration, transactional systems, customer-facing endpoints, while shunting bulk or best effort traffic to lower classes. Security controls then ride alongside rather than in front, sized and prioritized so decryption, inspection, and logging keep up under busy conditions. You confirm the alignment with dashboards that show queue depth, drops, and latency per class, and you adjust the knobs when an application's reality diverges from its label. In practice, this avoids a common failure mode, a spike in software updates or backups that, left unshaped, ruins the experience for revenue-producing flows and causes teams to blame the very controls that protect them. Identity and tagging pull these platforms together so policies follow people and devices consistently across segments and sites. Directory groups, device certificates, and workload tags become the stable handles you reference in DLP channels, UTM rules, NAC outcomes, and QoS classes. When a person changes roles, their entitlements and enforcement follow. When a service scales out, its tags bring the same controls to each new instance without manual lists. This reduces the number of places you need to touch and raises the quality of evidence, because every decision cites an identity or tag that has meaning in the business. Over time, the network feels less like a maze of addresses and more like a set of named relationships that you can audit in plain language. Monitoring policy outcomes closes the loop between theory and lived experience. Track blocks that prevented unsafe actions, bypasses you granted temporarily, and coach events where users received guidance and chose safer alternatives. Review these signals with product owners monthly, not merely with security staff, and categorize the top handful of reasons policies fired. When a rule produces many bypasses with sound business justifications, you either refine a rule or build the sanctioned path it is implicitly asking for. When a block keeps hitting the same automated process, you re-examine identity and scope so machines can do their job without special pleading. Evidence-driven iteration keeps friction low and protection high because the data tells you where understanding and configuration differ. Performance and failure behavior must be validated on purpose rather than discovered in an outage. Measure the incremental latency of DLP inspection on the channels you enforce. Assess UTM throughput with and without decryption, and stage NAC flaps to understand reconnect times under load. Document whether each control fails open or closed during maintenance and outages, and decide where that stance is appropriate. Production data paths should prefer safe failure that preserves integrity, while collaboration tools may tolerate a temporary lift if the alternative is a broad work stoppage. Announce these expectations to stakeholders so there is no surprise when a device loses access during a certificate rollover or when a bulk upload slows under DLP scanning. Predictable behavior is part of trust. Audit artifacts turn good intentions into durable proof. For each control, capture current policies with version history, rule hit summaries, exception tickets with timestamps, and outcome reports that link actions to identities and devices. Keep a small corpus of redacted examples: one blocked email with exact match evidence, one NAC remediation with posture attributes, one UTM prevention event with signature identifier, so reviewers can see how decisions look in practice. Store these alongside change approvals and performance baselines, and keep them accessible to both security and operations. When a question arises from a customer, regulator, or internal owner, you can answer in minutes with artifacts instead of opinions. Every estate has pitfalls that need direct fixes, not hand-wringing. Overbroad DLP patterns that flag everything numb users and desensitize responders. The remedy is to tighten classes with fingerprints and context so blocks are rare and justified. Policy sprawl across UTM stacks creates contradictions. The remedy is to collapse overlapping rules, remove deadwood, and apply templates that encode your hierarchy. Unmanaged agent versions for NAC or DLP cause inconsistent behavior. The remedy is to pin versions, automate updates, and alert on drift. Each remediation should be specific, time-bounded, and paired with a metric that proves the improvement. Fewer false positives, lower latency, cleaner logs, so you can see the result rather than hope for it. A scenario makes the balance tangible. Suppose a product team uses an unsanctioned cloud drive for ad hoc partner file sharing, triggering DLP blocks on outbound uploads. Rather than whitelisting the domain and eroding protection, you work with the team to define the sanctioned path, a vetted exchange with identity-tied links, per-file policy, and audit trails. DLP policies shift from blanket blocking to coaching for specific data classes when the destination is the sanctioned service, and remain strict blocks to generic drives. For a narrow, documented partner workflow that cannot move immediately, you grant a time-boxed exception bound to identities and device posture with a canary tag that raises visibility. The outcome is continuity for the business and preservation of data handling standards. Quality of service ties off the scenario by ensuring the sanction path does not drown other priorities. You classify the vetted exchange as a critical service during partner windows and confirm that UTM and DLP inspection remain within latency budgets. Monitoring shows upload rates, queue depths, and block/coach ratios before and after the change, giving both teams a shared picture of impact. If the sanction path needs more headroom, you adjust QoS and schedule bulk transfers out of peak hours, documenting the new profile so alarms use the right expectations. The story ends with a controlled flow that is safer, faster, and easier to explain than the shadow alternative it replaced. We will close by directing a small, measurable pilot that tightens one channel's policy with clear before and after metrics. Choose a single data class on a single channel, such as source code via web uploads. Define precise DLP matching with fingerprints and proximity, and set actions to coach for low-risk destinations and block for public ones. Confirm that UTM inspection and QoS classes keep latency within budget, and require NAC posture for machines allowed to use the sanctioned path. Run the pilot with a willing team for 2 weeks. Collect hits, bypasses, coaching acceptances, and transfer success rates. Then publish a one-page summary. If the results show reduced risk with stable productivity, expand the pattern. If not, adjust and retry. The aim is steady optimization guided by evidence rather than blanket prohibitions or blind trust. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.